Nothing's escaping, double check. Let's turn it. All right, boys and girls. Welcome to another episode of Chemistry at Burbank High School. All right, I'm Mr. Smith and Mr. Iwan's working the camera there. And this is this little demonstration, hopefully if it works, should work, is going to demonstrate what we've been talking about in class, balancing, right? Chemical reactions need to be balanced. All right, so what we're doing here is we're taking liquid water and we're zapping it with electricity. And that electricity, that energy will cause the water to decompose, right? And you should get, right, so I've already balanced it, right? We've already talked about balancing. So I've already balanced it. All the atoms are balanced on both sides of the arrow, right? And the liquid water will turn into a 2-to-1 ratio of hydrogen gas to oxygen gas. So we're going to show you, we're going to prove to you through this experiment that you do get a 2 hydrogen gas to 1 oxygen gas ratio. Okay? So it might take a few minutes, so we'll edit. All right, but here we go. So just
okay.
Yeah,
I
just gotta
zoomed
wait a
in
minute.
on it so they can see.
let me get the, okay, so you can already see the hydrogen is producing about twice as much, right? And then I'll do the pop. Okay, so let me get the other lab while we're waiting. What's the next one?
Yeah, it looks pretty good. It's about 2-to-1.
All right, I think we can give it a shot.
Okay.
You ready?
Yeah.
Okay, boys and girls, so we've let the water be zapped with electricity for a few minutes now. And you can see, this is the hydrogen gas over here. You can see there's about twice as much as oxygen gas. Okay? And if you look down here, you can see that the hydrogen gas, that's the bubbling, right, the fizzing, is being produced, you can look at it, it's being produced much faster than the oxygen, okay, in about a 2-to-1 ratio. All right, so just proving the 2-to-1 ratio. Now, to further prove that this is hydrogen and this is oxygen, I'm going to light this wood splint. Okay. Get it nice and on fire. All right. Okay. And oops. How? I'm going to collect some oxygen and stick it in here and the splint, and the oxygen should cause the splint to relight, to flare up. So let's see. Can you hold that, Mr. Island, real quick?
Yeah.
Thanks. All right, so I'm going to open this up and let some oxygen in here. Okay, go ahead and stick that in there, Mr. Island. Can they see that?
No, let's bring it
Right,
down.
let's bring it here. And look at that. See that lighting back up? That's the oxygen. Okay, did we get that?
Yeah.
Okay. And they still, from what my brother-in-law told me, that they still use this test when they go down in caves. They will light a big torch, blow it out so it's, what's the word, smoldering, and they'll just keep walking down into the cave, and if it lights back up, they know there's plenty of oxygen.
Oh.
And if it doesn't, they back out. So they still use that test. My brother-in-law is involved with government type stuff, so kind of knows what's going on. All right, so let's prove that this is hydrogen over here. Okay, now hydrogen is very volatile. It's very explosive. And again, here's the hydrogen. We're going to try it again to prove that it's hydrogen. Ready? Okay. All right, so I'm going to collect it. And ready, right there. Oh, you heard that little pop? That's as good as it gets. But you heard that little pop, right? That poof. Okay, that confirms the presence of hydrogen. Certain years I've gotten better pops. All right, but we'll try it again. We're going to do actually another lab, record another lab where we're going to do the same thing, and it should pop really good. So anyway, but you heard that pop. That confirms the presence of hydrogen. All right, hydrogen is very flammable. That's what the famous Hindenburg blimp, right, was made. I don't know why they filled it with hydrogen. It could have been any kind of spark or anything that caused it just to... Okay, so you saw a miniature version of that just now. All right, so that's that. All right.